Now let us see a problem on how this hydrostatic force is applied. So the problem is the hinged gate of length 5 meter inclined at 30 degree with the horizontal and with water mass on its left is shown in the figure. This is the figure, and the density of water is 1000 kg per meter cube. Minimum mass of the gate in kg per unit width required to keep it closed is. So the given data is the length of the this gate is 5 meters, and the angle that is making with the horizontal is 30 degrees. This is 30 degrees with the horizontal, and the density of water is given as 1000 kg per meter cube, and this is the free surface of water, the minimum mass of the gate. So mass of gate is equal to what per unit width to keep it closed is. So what are the forces that are acting on this gate? First we need to write the forces, which forces are acting on this. So firstly, the weight of this gate is acting in the downward direction, or let me draw it a little big here. So this is the gate, and this is the hinged one. This is 30 degrees, and this is also 30 degrees, and this is 5 meters. And now the forces acting on this are, firstly, this is weight of the gate. This is the center of gravity of that solid plate, and the hydrostatic force will be acting on this plate at a distance of hcp. So let me say this is h bar, because the distance between the free surface and the center of gravity is h bar, and the distance between, this is the center of pressure, distance between free surface and the center of pressure, the center of pressure is h star or hcp, and here there will be hydrostatic force acting perpendicular to that, hydrostatic force of perpendicular to the plate. So there is W and there is F. If we find the force F, we can find the W by equating the moments, since the gate is in closed condition, that is rest, so that it is in equilibrium. So how to find that force? We have seen that force is equal to WA into H bar, but where it acts at a distance of hcp from free surface, or h star from free surface. So first we need to find the force, which is equal to W rho G into A into H bar. So what is rho? 1000 kg per meter cube into G is 9.81 into area. What is the area? The area of this plate is 5 meter into, it is said that consider it as unit width. So unit width is 1 meter. That will be in third dimension, which is inside the screen. So into what is H bar? H bar is the distance of a center of gravity to free surface. So from here to here it is 2.5 meter, and we need to find H bar. So we can say that sine 30 is equal to H bar divided by 2.5. So H bar is equal to 2.5 sine 30. Sine 30 is 1 by 2. So it is 1.25 meter. So H bar is 1.25 meter. So what is the force is? If we calculate this, we will get a value 61312.5 Newton. That is the value of force that is acting on hydrostatic force that is acting on that plate. And now we need to find this distance. Let me see. Sorry, this distance. Let me say this distance as A. So we need to find that distance A. So how to find the distance? Okay. First we need to find the hcp or h star. We know that hcp or h star is equal to h bar plus igg divided by ah bar into sine square theta, where theta is the angle that is making with the horizontal. So we have got h bar as 1.25 meter plus igg. Igg is equal to bd cube divided by 12. here b is the width inside the screen, so that is, consider it as unit width. 1 into depth is this is the depth for this plate, so 5 cube divided by 12. So IgG is 5 cube divided by 12 into area. Area is the surface area of that plate is 5 into 1 into h bar. H bar is 1.25. And next into sine square 30. Theta is angle made with horizontal, so the angle made with horizontal is 30 degrees. Now, if we solve this, we get h star is equal to 1.67 meter. So h star is 1.67 meter. This is h star, and this is distance a. This is 30 degrees. So sine 30 is equal to h star by a. So a is equal to h star divided by sine 30. So a is equal to 1.67 divided by 1 by 2. So 1.67 into 2, which gives as a value 3.33 meter. So a is 3.33 meter. So if we make the moments, summation of moments is equal to 0, and summation of moments about a point O is equal to 0. So what are the forces acting on that plate? One is W. W is the force acting on the plate into the perpendicular distance from O. So from here to here, let me say that B. W into B, which is a clockwise moment, and minus this F into A, which is anti-clockwise moment. So taking clockwise as plus and anti-clockwise as minus, and equating it to 0. But we don't know the value of what is B. So in order to find B, cos 30 is equal to B divided by 2.5, since, or see here, this is h bar, this is h bar, this is B, and this is 2.5. So here we need to find B. B square is equal to 2.5 square minus h bar square. This is the Pythagoras theorem. So 2.5 square minus h bar is, what is h bar? It is 1.25 meter. 1.25 square. So B is under root of 2.5 square minus 1.25 square. So we will get the value of B as 2.165 meter. 2.165 meter. So by substituting it in this 2.165 minus, we got the force value as 61312.5 Newton into what is the value of A? A is 3.33 meter, which is equal to 0. That is all this, we will be getting 61312.5 into 3.33 divided by 2.165. So we will get W as some 94305 Newton. And the question asked is in terms of mass. So W is equal to mg, and m is equal to W by g, and 94305 Newton divided by 9.81 yields us the value m is equal to 9613.16 kg per, this is per unit width, we have calculated per unit width. So the option is, where is this? So 9623, approximately it equals to this value. So 9623 is the answer.